haven't talked, or we're going to talk about today, we already know. Okay, we're going to just define a few things. So the first part is talking about the interior angles of a triangle. What does interior mean? You're about to make me take it. Inside, okay? So we're talking about the angles that are inside a triangle. So in this first blank, what we are going to write is an interior angle of a triangle. And I just draw the shape instead of writing the words because I can. Okay. An interior angle of a triangle is the angle at the vertex, so at the corners of your triangle. How many angles, interior angles, do we have? Three. Okay. Because a triangle has three vertices, that's the next blank, and those vertices are the corners, three corners. Then we have three interior angles. And we've talked about this before. This is an actual theorem here, the triangle angle sum theorem. Says that the sum of the measures of a triangle is how much? 180. Okay, so you need to make sure that you remember that. All three angles of a triangle that are inside of the triangle add up to give me 180 degrees. And we're going to use that a lot today. And then we're going to talk about two different ways to classify triangles. You can classify them by the sides or by the angles. Okay, does anybody remember? There are three names for triangles classified by their sides. One of them is where none of the sides have the same length. It starts with an S. Might not remember. Might not have heard of it for a while. It's called scalene. That is, sorry. If I could get my pen to write would help. Oh, come on. Hold on, battery's not working. It's called scalene. That is spelled S-C-A-L-E-N-E. And that is a triangle who all three sides have different lengths. So one side would be 3, one side would be 4, one side would be 5, okay? Those are called scalene triangles. Then we have a triangle that has two side lengths that are the same. That is isosceles. Okay, isosceles is a triangle with two of the lengths that are the same. And then the third one would be all three sides are the same. Does anybody remember what that's called? Starts with an E. Equilateral. Okay, so if I'm classifying a triangle by its side lengths, it's scalene, it is isosceles, and it is an equilateral. Scalene means all three sides have different lengths. Isosceles means two sides are the same. Equilateral means all three sides are the same. And then we can also classify them by their angle measures. You should know these. There's three of those. Acute. Acute is where all three angles are less than 90. Obtuse is where we have one angle that is greater than 90. And then we have a right. Okay, those are by the angles, describing what sizes the angles are. Acute, obtuse, and right. Everybody ready? Anybody have any questions so far? All right, for our first example, we are trying to find the measure of the three missing angles. We're looking here at angle 1, angle 3, and angle 2 is what we're trying to find the measures of. How many triangles do I have in that picture? 2. Technically 3, right? You have the two small ones and then the big one. So we can do this a couple of different ways. Which triangle has at least two angle measures in it, the left one or the right one? The right. So can I figure out what the measure of angle 2 is pretty easily? So what are we going to do? What are we going to add together? It's 57 though, but yeah. So we're going to add the two angles, 57 and 71. And that's going to give me 128. And then what would I do to find angle 2?
Subtract that by
Subtract that from 180. Again, if my pen would write, would help. Okay, so I'm going to do that subtracting. So what does that give me? 52. So angle 2 is 52 degrees. You can just write it next to it in the picture. Everybody okay with that? Mm-hmm. Right. Now, I need to find the measure of angle 1 and the measure of angle 3. I can do it a couple of different ways. But what I want you to look at is right here in the middle. What do these two angles that I just highlighted in blue give me? 180. So I can figure out angle 1 by doing 180 minus 57. So that's going to give me, what, 123? Okay, so angle 1 is going to be 123 degrees. And then how could I find angle 3? What two numbers do I add together? 123 and 28, yep. That's 11, that's 5. And then what do I do with that 151? Subtract it from 180, yep. And I find out that that angle is how many degrees? 29. So we can find missing angle measures using the triangle angle sum, which means all three angles of a triangle add up to be 180. We can also use the linear pair that we did, the 57 and the 123. And then we still have like vertical angles that we talked about and all the other angle pairs. So any of that we have already learned can be used in any of these. Everybody good so far? This way? In that next blank, it says that we're going to talk about the triangle angle sum corollaries. So the first blank says a corollary. That's C-O-L-L. Are you spelling this? C-O-R. Writing in that blank right there. C-O-R. C-O-R-O-L-L-A-R-Y. Corollary. And a corollary is just a different theorem that follows from a previous theorem, okay? Not that you have to know what the definition of corollary is, but you do need to know what the corollaries are, and they are listed right under you. Look at that corollary 5.1. What does it say? The angles of what? Come on, read it. The acute angles of a right triangle are complementary. Okay, so let's think about this. If I have a right triangle, how many right angles are going to be in that right triangle? 1. Okay. And then let me give you a for example. If one of these is 30 degrees and one of these is 60, what this corollary says is that these two angles are complementary. What does complementary mean, Derek? Well, put your phone down. Stop playing with it. Just put it on there. That means they add up to be 90, right? Do these two add up to be 90? Yes. I could also do something like this. If this were 20, that would have to be 70. Do those two still add up to be 90? Yeah. So any right triangle, the two acute angles are always going to add to be 90. Corollary 5.2 says there can be at most, that means no more than, one right angle or one obtuse angle. Okay, if you think about this, how many degrees is a triangle? 180. If I added two 90s together, that would give me 180 already, wouldn't it? How many angles does a triangle have? 3. That was only 2, okay? So you can only have one right angle and one obtuse angle, or one obtuse angle in a triangle, not more. Everybody ready? All right, I want you guys to try number 1. That's very similar to the question that we did up above. The left one or the right one only has one missing angle?
Left.
The left. So to find that missing angle, I'm going to add the 2 angles that I have, the 46 plus the 80, and that's going to give me what, 126? But that's not my angle. That's not my missing angle. That is what is taken already. So I have to do the total triangle, 180, minus the 126, which gives me 54. So angle 1 is going to be 54 degrees. Is everybody okay with that? Now the other triangle is missing 2 angles, so I have to find one of them before I can find the third. The only relationship I see are these 2 angles right here that give me a straight line. How much is a straight line? 180. So if I have 180 and I take away the 80 that I am given, what would that be? So angle 3 is going to be 100. And then what would I do to find angle 2? And then do what? And so that's going to give me 42. Is everybody okay with that? Yes, no, maybe? Yeah, okay. Okay. Try 2. Saying we're taking the 2 angles on the right triangle, the 34 and the 34, okay, on the right side, we're adding those together. And then we are going to subtract that from 180. We get 112. So what is angle 3 going to be? 112. Say that one more time. Not yet.
Is that what you're going to do?
In a minute. Not that exact thing, though. Let me ask you a question. Look at the 34-degree angle and angle 2. What do they give me together? 180. And so to find out angle 2, I'm going to do 180. Well, hold on. I'm finding angle 2, which is the outside of the picture.
I thought angle 2 was 34 because it's an arrow pointing toward.
Hold on. Oh my goodness. Now, the angle that you're talking about that is 34 is this one. Do you see where I just wrote 34 in the gray? Yeah, which coach? Okay. Do you see where I wrote it in gray? Now, how could I find angle 1? Add 85 and 34.
So whenever it's freaky like that, just know both of them equal on both sides.
Yes.
Okay.
All right, and then I'm subtracting that. So what is angle 1 going to be?
I'm ready for the homework.
I did get 119, but I didn't get 119. I don't know what you did.
She got the 34.
All right, hold on. Okay. Start with this triangle. Do you notice that you have 2 out of the 3 angles for that triangle? The one that I just blew up, the 58 degrees, the 65, you're missing angle 7, yes? Okay, so to find angle 7, what are we going to add together?
58 plus 65.
Okay, we're going to add, maybe, if I would get my pen to write one, help. 58 and 65. And then to find angle 7, I'm going to take that away from, yeah, 57. Okay, so angle 7 is 57 degrees.
Okay, so when we do that, does 57 go to 5,
Yes.
and then we add it together, 67, 57.
Yes.
I go across the 5 and not across
Because
the
it's
6.
vertical. It's vertical.
Remember, vertical angles are directly across from each other. They're not next to each other, but across from each other. So which angle is across from 57? 5. So that one is also 57.
And then when you get that, what you supposed to do it like?
Hold on. Let's get angle 4 first.
Alright, it's 60.
67,
Mm-hmm.
57 equals
Come
123.
on, bro. It's too much talking. Man.
Mm-hmm.
Damn. Dang. Sorry.
Y'all are giving me a headache.
Then it'd be 56.
Okay. So angle 4 is 56. Is everybody okay with how we got those 3 angles? Okay, before I make your head hurt. Yes? So I found one angle, used the vertical, found the other. Okay, so now if you notice that bottom triangle, I don't have any angles here. But what I do notice is these little markings for 8 and 9. What does that tell me? That says those 2 angles are,
That's 90 degrees already.
nope, 90 is a box. Those 2 little curves tell me that those angles are congruent. So they're going to be the same. But what I have to look at first is finding angle 6. What do these 2 angles give me together? 180. So I'm going to find 6. Yes. And so that's going to give me what, 123? So angle 6 is 123.
It's across from the
Wait, they got 123.
Yeah.
Oh.
Okay, so if my triangle is 120 degrees, and I know my one angle is 123, I know the other 2 are exactly the same. The first thing I want you to do is tell me what is left out of 180 if I take away 123. So we're going to go 180 minus 123 gives me 57, right? Are we listening? Okay. That doesn't mean angle 8 is 57 and angle 9 is 57. That means the 2 of them are exactly the same, and together they give me 57. So how would I figure out what they are? What would I do with 57 to figure out what each one is? Divide it by 2. Okay, so I'm going to do a calculator because that's not an even number. 57 divided by 2 gives me, yes, angle 8 is going to be 28.5, and angle 9 is also 28.5.
Tell me we're never ever going to have the rest of the and God.
That's not that hard, bro.
So you're not gonna promise me?
Well, you can now. You write it twice and you just foil like that.
Yeah, like that.
Mm-hmm. But that's going to be 9y. What's y times y? Y.
Oh,
Mm-hmm. Is everybody good?
Not really.
No.
Okay, we're going to just skip that last example because